So welcome back again, my dear students. This side Govind Govind sir, your chemistry mentor, and you are watching this video on my YouTube platform Govind Chemistry. Hope you people are doing good. We are completing the thermodynamics series, and this is the lecture number 13. Lecture number 13 in the thermodynamics series. Till the last video, we have discussed about the second law of thermodynamics and criteria to decide spontaneous and non-spontaneous process. So last day I told you there are three variables: entropy change, enthalpy change, and Gibbs free energy change. Now criteria number one. So maybe some spelling difference you can manage, but ultimately the aim should be clear. The first point is criteria. The first criteria is tendency to lower its energy. Okay, so lower its energy. When energy will be lower for the substance? When it is releasing the energy. When it is releasing the energy, then delta H, change in enthalpy, will be negative. Okay, so any process, children, any process, if energy of system decreases, energy of system decreases, then what happened? The process will be spontaneous. The process will be spontaneous. Like A to B reaction is given and plus energy release. If energy release, then this process is spontaneous. Because it is a delta H is negative, then process is exothermic. If exothermic, then it is spontaneous. So few examples we will discuss. Like H2 plus half O2, both are in gaseous state. They are forming H2O gas. In that case, delta H is minus 280 kilojoule per mole, or mole inverse you can say. So this is a spontaneous process because of exothermic reaction. Similarly, carbon solid to CO2 gas, here also delta H value kilojoule per mole. So if delta H is negative, then process will be spontaneous. But children, here we are having some problem. Many endothermic process are spontaneous. So you can say that right now, sir, you said that if delta H negative, then process is spontaneous. Then what about this? If energy absorbed, then also process is spontaneous. Delta H value is positive, then also process is spontaneous. So first I will give you example, then I will give you reason. Like ice, solid state to converted into water, liquid. What is delta H when ice is converted into water? When it will absorb energy from the atmosphere. So delta H positive. Similarly, water, liquid to water vapor, That process is also spontaneous. Yes or no? Evaporation of lakes, HGO solid state to converted into mercury liquid to half O2. Here also delta H positive. Here also delta H positive. So these all are endothermic reaction, even though these processes are spontaneous. Sometime delta H zero also. Which reaction? Check it. CH3COH carboxylic acid C2H5OH. Here CH3COO C2H5 esterification. What it is? Ester. So this process is also spontaneous. So the criteria is fail. That means negative value of delta H only cannot decide the process is spontaneous or non-spontaneous. Okay. Then what we have to do? How to identify? Don't worry, I am with you. Now the second criteria, second point, tendency to acquire maximum randomness. Now this will decide the process is spontaneous or non-spontaneous. Randomness means what, children? Anything which is order to disorder. If system is going from order to disorder, then order means there is only one way, and disorder means many ways. Like in a box there are 100 coins, and you are tossing all the coins, and the probability of all you are getting all head, less probability. Yes or no? Yes. All head is how it is possible, but random number is possible. 2 head, 8 tail, 7 tail, 3 head, like that. So in this case, system low probability moves to high probability. That is called randomness increases, or you can say organized pattern to disorganized. If organized to disorganized move, then randomness increases. Suppose you are coming in your school and going to your class, so there are less chance that you will sit on one place always. That is only organized pattern, but you will sit every day in different places, that is disorganized. Okay. So for disorganized there are many way, and for organized there is only one way. You can understand like this also. Mixing of gas. And here cork is applied. Here gas particles are filled, gas A and gas B. When you remove the cork, then what happened, children? Gaseous particle will intermix. So here also A and B, and here also A and B. So from here to here randomness increases. So if randomness increases, then process will be spontaneous. So mixing of gas is what process? Is spontaneous. Okay, that means you can say change in entropy change delta S should be greater than 0. If randomness increases, then entropy change will be greater than 0. Like what? Check it. Ice, solid state to water, liquid state. So ice is an organized system, solid is what? Packed structure, and water is what? Disorganized system. So from ice to water, what? Randomness increases, although here delta H is positive, but delta S is greater than 0 because randomness increases. So this process is spontaneous. Okay, got it? But here also problem came, children. What, sir, again and again you are saying problem? Yes. Tell me one thing, liquefaction of gases. Liquefaction of gas. So here gas is there and it is liquefied into liquid. So gas is what? Gas molecule are like this, unorganized system, and here liquid is what? As compared to gas, it is organized. If it is organized, then here randomness decreases. Delta S is less than 0 because randomness decreases. But in that process delta H is what? Negative. Gas to liquid, then condensation required, heat release. So this process is spontaneous. So there are confusion between entropy and enthalpy. These both functions are not able to decide clearly the process is spontaneous or non-spontaneous. Okay. So here I am erasing this now. Check it once. So randomness increases. That means disorganized. So entropy, that is your S, is measured in what? It is measure of randomness. Entropy is what? Measure of randomness. Okay. So we will talk about delta S because we cannot measure S only. Change in entropy will be measured as final minus S initial, and that value should be positive. Then system will be spontaneous. Okay. If any system A to B is spontaneous, then B to A definitely non-spontaneous. Yes or no? Here delta S will be negative. Here delta S will be positive. If A to B in equilibrium delta S will be 0. In equilibrium delta S will be 0. So once again, entropy is a state function. It's only depend upon the final and initial condition, children. It does not depends upon the path followed by the system. Okay. So let's talk about entropy again. Important point. Important points of entropy. So small thing, it is entropy is a state function. That means delta S is equal to product minus reactant. One question I am giving you here, pressure versus volume graph. In that graph, x to y, y to z, z to x is given. That was one question in JEE, but it is not like that. I am asking in true and false only. So in that case, entropy of x to z is equal to entropy of x to y plus entropy of y to z. Okay, is correct or not? This statement is true or false? So from here, check it, children. Delta S, change in entropy for x to z, is equal to what? Change in entropy delta x to y plus delta S y to z. So this statement is true. X to z, it's a cyclic process. X to z, so x to y and y to z. One more previous year question from the JEE only. Find one process is given. A to C, C to D and D to B. Find delta A to B. Find delta S A to B. And here some values given. Delta S A to C is equal to 50 EU. EU is the unit, okay, unit of entropy. Delta S C to D 30 EU. Delta S B to D plus 20 EU. And options are given: plus 100 EU, plus 60 EU, minus 100 EU, minus 60 EU. So how to do, children? C to A means what? A to C means what? How can you write it? C A to C. So change in entropy, how to write? C minus A, yes or no? Final minus NaCl, that is 50 EU. C to D, how to write? D to entropy of C, D and entropy of C plus 30 EU, B to D. So entropy of D minus entropy of B is equal to 20 EU. And what is required? Required is A to B. So S, B to A, that is required. So how can you do? You have to add all these. If you will add, then SC cancel and reverse it, this third equation. I am reversing, then it will be reverse. So it will be now SB to SD, and its sign also minus, will be a reversing. So minus 20 EU. So what happened now? D to D cancel. What you are getting? SB minus SA is equal to what? 60 EU. So 60 EU is your answer. Okay. So like that. In that case, mathematically, delta S is equal to delta Q upon T. It is represented. T is equal to constant temperature. Q is equal to change in heat, that you know, if positive sign then gain, if negative sign then lose. Okay. For a small function, ds is equal to dq upon t. If t is not constant, then this formula you will apply. Delta S is equal to dq upon t. Unit it will be joule, mole Kelvin, or calorie, mole Kelvin, or urge, mole Kelvin. Its extensive property depends upon the amount of matter. Okay. Now learn about isolated system and non-isolated system. Isolated system is what, children? Suppose the same process, mixing of gas, gas A, gas B, and this wall is insulating. This wall is insulating material. Then heat exchange, delta Q is 0. In that case, when cork is applied, when you will remove the cork, then what happened? A and B mix. Here delta Q is equal to 0 because it is insulating material. But entropy what? Randomness increases because mixing of gas. So delta S value increases. In that case, delta S greater than 0. It is for system. Okay. So here there is no matter of this Q. This Q, there is no matter for Q. So isolated system, they are spontaneous. Isolated system, they are spontaneous. Entropy will be greater than 0. For here only we have to check the entropy for system, because surrounding it is not exchanging any kind of heat, children. So here we have to check the entropy of system on that basis, because Q no matter. Now come to the non-isolated system. Non-isolated system, children, that means system plus surrounding. So here you have to check change in entropy of system plus change in entropy of surrounding is equal to total change in entropy. Here surrounding no matter. So for the spontaneous process, delta S total should be greater than 0, then process will be spontaneous. Okay. Or you can say delta S for universe also it can represent. So delta S for universe is greater than 0 in the nature. Which process? Irreversible. Okay. So in the isolated system there is no use of Q, but here we have to check. How to check? Check it, children. Suppose it may be boring, children, but you have to understand. Any condition is given minus 1 degree Celsius. Minus 1 degree Celsius liquid will be converted into ice. Yes or no? Yes, definitely. In that case, liquid with what? Heat release. Here heat release, and system is heat release, then process is what? Spontaneous. But delta S of system, liquid converted into the ice. What is going on here, children? liquid is disorganized system and ice is organized system. So here it is not greater than 0. Delta S is not greater than 0. But S of universe is greater than 0. Now you will be confused. Wait 1 minute. Because here it is not a isolated system. Okay. Delta S for system is equal to delta Q delta T. Here energy release. So delta enthalpy change of system is negative, right? That means delta S of system is less than 0. But in the case of non-isolated system, we have to check the delta S of surrounding also. That is greater than 0, much more greater than 0, always. That is why I said S of universe is greater than 0. So in the non-isolated system, you cannot take decision on the basis of system entropy only. Surrounding also you have to check. Like what? I am giving you one example. 30-minute disturbance. Here I am writing temperature in degrees Celsius, delta S of system, delta S of surrounding, and delta S total. In that case, and this is set up at 1 atm. So here I am giving you data -1, and the process is H2O liquid to H2O solid. Here it is -21.85 and here plus 21.93, so plus 0.08, 0 minus 21.99 plus 21.99, and it will be 0, plus 1 minus 22.13, 22.205, and it is minus 0.08. So check it, children. Water to ice, water to ice. In that case, heat release, but delta S total is greater than 0 in this case. Okay. Plus 1, this is -1 degree Celsius. Plus 1, here check it. Delta S total is less than 0. So it is non-spontaneous. It is non-spontaneous process. heat of system is less, negative, and heat of surrounding is positive. But in the case of this 0, here delta S total will be 0 in equilibrium. 0 degrees Celsius, 1 atm pressure, that is reversible process. At that time, enthalpy change delta S of system is equal to minus delta S of surrounding. That you have to remember. Based upon this, we'll solve one question. H2O liquid to H2O gas, delta ST is equal to 0. 1 atm pressure, 373 Kelvin temperature given. 4 options are given. Delta S of system is greater than 0 and delta S of surrounding is second option. System and surrounding you will assume. Third option, fourth option. Which will be correct? C will be correct. Why? From liquid to gas, then what happened? Heat absorbed. That means system enthalpy change is positive, greater than 0. Delta S of system. And second case, because delta S is what? Delta QT, and it is positive. In second case, it is less than 0. Surrounding less than 0. If it is greater than 0, definitely it will be less than 0. That's it. Next is, children, reversible process and irreversible process. Delta T for reversible process and for irreversible process. We talk about enthalpy change, entropy change in different thermodynamics processes. So number 1, isothermal. Isothermal means constant temperature. So suppose this is your system, temperature T and dq, and this is surrounding. Here also temperature T. It is releasing small heat, so delta S of system is equal to minus dq upon T, which is not equal to 0. delta S of surrounding, it is accepting, then dq upon T, which is also not equal to 0. So S total is equal to 0. That is for isothermal. Number 2, adiabatic, delta Q is equal to 0. So enthalpy change of system is equal to 0 minus 0 is equal to delta S of surrounding. Both will be 0. Okay. So this is for isothermal reversible. Delta ST is equal to 0. Irreversible, here delta T is greater than 0 to temperature and T1 is greater than T2. So here system temperature T1 releasing dq heat and surrounding T2 temperature. Delta H of system is equal to minus dq upon d1 T1. Delta S for surrounding is equal to plus dq upon T2. So delta S total is equal to minus dq upon T1 plus dq upon T2. From here dq is common, 1 upon T2 minus 1 upon T1. So delta S total is equal to dq T1 upon T2 T2 T1, which is greater than 0. Video is almost 43 minutes. Hope it will be 1 hour also. Time I have to check, and duty also. Give me 2 sec, children. So I have to go now. Till here we have completed. In the next video, we'll discuss about the process and derivation of the formula. Okay. Thank you.